Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. So this is our 12th class for this term for PLAR Science, and we're still on week 7, and it is our last class for this week. Just a reminder to students, you can still register for term 3. So term 3 is from June 24th to August 23rd. We have the following courses available for you. We have some English courses, math courses, science courses, and the history, and also offering the co-op education course. So if you want to sign up, you can use our online application form to sign up or register for courses, or you can also ask for a hard copy by simply calling the office, or you can check out our Facebook page. Michelle and Candace will be more than happy to help you with signing up. Also a reminder, this is coming up, the term 2B draws. So WASA will still have the 2 student draws for term 2B. Remember, students who submit their work, so if you are submitting your lessons, so each time you submit your lessons, your name will be added to the draw. Also, students who earn a credit, so if you complete all your lessons and then you do the culminating or test, that will also count as an entry for your name for the term 2B draw. So 2 prizes, one for students who submit their work and one for students who also earn a credit. Make sure you contact our office if you're needing any help with your work, or if you have any questions. Contact your teacher. So if you need to get a hold of me, you can reach me several ways. Again, calling me at the office. You can email me. You can send me a message on my work Facebook. My office hours are also available from your DEC, or again, you can ask me what my office hours are, and you may also call me at home. Options for submitting your work. Remember, you don't have to submit all of the lessons, or you don't have to complete all of the lessons before you submit them. You can submit work as you complete them. So for example, if you have completed 5 key questions, go right ahead and submit them if you're able to. Or you can submit it a lesson at a time. But don't keep the lessons, for example, students keeping lessons 1 to 5 that's already been completed and then waiting to send it all at one time. Just in case that you're doing something that is incorrect, you don't want to keep repeating it. Then that means you'll have to redo or resubmit those questions. When you're sending them out, you can have your DEC fax, or you can do it yourself by scanning, emailing it to studentwork@nnec.on.ca. Make sure that you CC the teacher that's marking your work. Again, you can send a picture through Messenger. This seems to be popular, and that's fine. It means that you have a copy of your work, and we can just print it on this end. You can also drop it off at our WASA office. So there is an outdoor mailbox on the side entrance, or you can knock on the door and just give it to reception. If you're needing more support in completing your key questions, you can go to YouTube. Both Bonnie and I have our YouTube profiles. We have on the playlist classes. So if you are working ahead in PLAR Science, you can go to PLAR Science 1B 2023-24. Let's say you're working on lesson 5 already and we're still on lesson 4, you can go there. You can also check out PLAR History 2A. All 10 videos are designated for PLAR History, and then for PLAR Geography, we have 8 videos for that. So far I have 12 videos for the PLAR Science. Which makes this class, the 13th class, not the 12th. when you go to the class or the video, if you requested a USB of classes, when you open these classes, each class is named. So for first, it will be the component or the subject. So in this case, it will say PLAR Science. Then after that, it will give you the lesson number. So lesson 1, 2, 3, 4, and so on. And then it will give you the key questions that's on that class. So if you're needing help with key questions 45, you would open PLAR Science lesson 3, key questions 44 to 48, because key question 45 will be in there. So again, we are in week 7, so we are looking at lesson 4, physics, and next week, week 8, so we've got about 2.5 weeks left. We will only need another lesson perhaps for lesson 4, and we will start next week with lesson 5. Again, lesson 4 is not very long, and then you can have a chance to write the PLAR Science culminating at the end of week 9. Remember, you need to do the culminating. You need 50% or over. I will give you the culminating, or I will have your DEC give it to you for you to complete. Remember, as soon as you get it, try to complete it as soon as you can. There's no time limit, meaning that in the past we have sent a test and you had 2 hours to complete it. Okay, in the culminating activity, again, there's no time limit. You don't have to be supervised, but you should complete it as soon as you get it. Okay, don't keep it for days. So here is the mark sheet. So if you have sent work in, you will receive a mark sheet. It gives you the key questions number from 1 to 80. We completed as far as key question 64 in lesson 4, and we also looked at key question 66. So today we will look at key question 65 and key question 67 and key question 68. So let's see how far we get. So just to direct you, on the cover page of lesson 4, it will give you the same information that I just went through. So if you're needing anything, you can look through or look at that page. If yours doesn't say 2023-24, do not panic. So if yours says 2022 to 23, that means that was last year's version. If you have completed key questions using that version from last year, that's fine. Okay, I will still mark your work from that version. Okay, you don't need to redo your key questions. Just let me know that hey, I don't have the newest copy and I'm using the old version. As long as you complete the key questions, that's fine. Okay, so we have for the learning goals, I can explain the laws of electrostatics, or if you prefer, if you don't like using that term, you can use static electricity. Means the same thing. And then I can describe the similarities and differences between current and static electricity. So we looked at page 3 on Monday, electrostatics, and then types of charges on page 4. So we'll do a quick review on that. So we started off with physics on Monday. So we said that physics involves the study of motion, so movement, different forces, for example, gravity, energy, momentum, and other concepts. So in this lesson, we'll be examining principles of electrostatics or static electricity. There's also branches of physics, and that includes electricity, astronomy, motion, waves, sound, and light. So here we go. Here's a quick review. We said that electrostatics, also known as static electricity, that is the branch of physics that deals with apparently stationary electric charges. So stationary means not moving. Electrostatics involves the buildup of charge on the surface of objects due to contact with other surfaces. So we looked at all these pictures on Monday. We said, for example, when you have a plastic comb and you run it through your dry hair, static energy is produced. If you're in a dark room, you will notice sparks. Same as when the comb is run through dry hair, the hair which is dry starts breaking and falling apart, just like here with the girl. She pulled the hat from her head. Notice that her hair is standing up. You can see the strands of it, and it starts to move apart. You could also do this when you have a plastic comb is rubbed on a woolen cloth. A static electricity is generated, and because of this, the plastic comb can attract small pieces of paper. Okay, so that's that. So that's number 5. Also, if you walk on the carpet floor and you get a shock when touching a doorknob or perhaps other metal object, that's probably one of the best examples of static electricity. And you can see the person there, he's got a sock that's stuck on the back of his shirt there. So after being in the dryer, when the clothes get stuck to one another, again, that's an example of static electricity. So all these pictures you just saw, that's all caused by static electricity or electrostatics. Then we looked at the 3 different types of charged objects. We said that an object having an equal number of protons. So remember, we looked at the atom, and the best way to remember the particles that's in an atom is if you spell the word pen. So P stands for protons, which means it's positive, so positive charge. E for electrons, and we said electrons are a negative charge. N stands for neutrons. Now neutrons are neutral. That means they're not positive or negative. We put 0 on that, meaning it's no charge. So an object has an equal number of protons and electrons, then that object is neutral. So if you look at this object, it has 8 protons, so 8 pluses, and it also has 8 minuses, so it balances. That object then is not positive, it's not negative, it's neutral. Okay, you'll need to know this for your key question, which is number 66. An object is positive if it has a greater number of protons, that means if it's positive, than electrons, which are negative. So all you have to do is you just count. So here you have 8 protons, so that means there's 8 pluses, and there are 5 minuses or 5 electrons. This means that this object, simply doing math, which is more, 8 or 5? So we know that 8 is bigger than 5. So 8 protons. So protons are bigger, or there are more protons than electrons, which gives us the overall charge, which is positive. and then we'll look at the opposite of that. An object is negative if you have the number of electrons greater than the number of protons. So count it again. There are 8 protons in this object. So remember P-protons, or if you look at the P for positive, it's one way of remembering it. Electrons, meaning negative. There's 12 of those. Which is larger, 12 or 8? So we can therefore say that there are less protons in this object, which gives us that this object is negative. Okay, so what we'll do, while that's fresh in your mind, let's look at that particular key question. Okay, key question 66. We did do the first one. So you're basically counting the protons and electrons. It says there, indicate the type of charge on each of the following objects and explain your reasoning. That means you tell me how you figured it out. So A, we said object A, we counted the protons. So there are 3. And then we counted the electrons, or the minuses. There are 5. So we determined that that object A is negative. And your reasoning, well, it has more electrons, because there's 5, than protons. So object B, again, count them. You have 5 electrons and 5 protons. So 5 and 5, they're the same. That means that that following object is neutral. And you can give me your reasoning for that. We just said that we have an equal number of electrons and protons. And then finally, object C, you have more protons than electrons. So I'm counting 5 protons, so 5. And then 2 electrons. That means that that object, the charge is positive. Okay, then provide your reasoning. Okay, next up. Okay, make sure you know this, that definition of atom, we have in the nucleus, you have protons, which are positively charged particles, and neutrons. These are particles with no charge because they have an equal number of pluses and minuses. And then electrons are negatively charged particles. That's what's orbiting outside of the nucleus. On page 5 of your lesson book, look at the heading, or the title. It says Law of Static Charges or the Law of Electrostatics. So there are 3 laws, the first, the second, and the third. So now that we know a little bit about the atom and the objects that can have different charges on them, let's look at how objects can be charged. So something that you should be aware of is the law of static charges. So the first law tells us that unlike charges attract. Or if you want to use the word opposite, you might have heard of the saying opposites attract. So opposite or unlike. So if you have a negatively charged object, it will be attracted to a positively charged object. So as long as they're unlike or opposite, they will attract. So if you have a positive object and you put it beside a negative object, there's an attraction, or vice versa. The second law tells us that like charges repel. That means if you have a negatively charged object, it will cause another negatively charged object to be forced away. Or if you have a positively charged object, it will repel. if you put it beside another positively charged object. So if you were to put plus beside each other, they will repel, or minus together, they will repel. Okay, like charges repel. The third law tells us that neutrally charged objects are attracted to charged objects. So if you put something that's neutral or neutrally charged, if you put it beside a positively charged object, they will attract. Or if you put it beside a negatively charged object, they will attract. So the key thing here is opposite or unlike charges attract. So in key question 65, simply asks you, what are the 3 laws of electrostatics? Or if you want, again, static electricity. So simply write 1, 2, and 3. For example, number 1, okay, unlike charges attract. Okay, you can finish 2 and 3. I gave you number 1 already. Okay, you just have to state what are the 3 laws of electrostatics. Okay, in key question, well, actually let's look at some more details for why we have unlike charges attracting. So if you have static electricity, it is created when positive and negative charges aren't balanced. So protons and neutrons, they don't move much, but electrons love to jump all over the place. So when an object or person has extra electrons, it has a negative charge. A good example of that is if you rub a balloon on your hair, some of the electrons rub off your hair onto the balloon. Okay, so it transfers because the electrons are what moves or jumps, which means that the balloon has gained electrons. So now it has a negative charge. In the meantime, your hair has lost electrons, so it has a positive charge. Okay, so if you're losing electrons, that means you still have the protons. So now the balloon is negatively charged, your hair is positively charged. If you hold the balloon near your head, your positively charged hair will be attracted to the negatively charged balloon. You may even hear a crackling sound, and you might even see a tiny spark. So the crackling sound and sparks are produced as the electrons jump from the balloon to your hair. Okay, so that's an example of the first law, unlike charges attract. Let's look at the second law, where like charges repel. This means that 2 positively charged objects will force or repel, or if you have 2 negatively charged objects, they will repel each other. One way to check this out is if you rub 2 balloons on your head or a piece of wool, both balloons will be negatively charged. If you try to touch the 2 balloons together, they will repel each other. Okay, it will not charge. You could try this experiment. If you open a tap very slightly, so there is only a thin, gentle stream of water coming from it. There's your water. There's a thin water flow. Charge a balloon, and you can charge your balloon by rubbing it on your hair or your clothing. Now move the balloon close to the stream of water. The water should be repelled from the charged balloon, so the stream of water is deflected. You will actually see the stream be forced away, okay, because like charges repel. Okay, so if you have a balloon handy, you can try that. Finally, the third law, neutrally charged objects are attracted to charged objects. This happens, and again, we can do this on an experiment, or you can try it at home. Charge a balloon, you can rub it on your hair or clothing. Now try to move the rub part of the balloon close to a wall. So the balloon should be attracted to the neutral wall. Okay, remember the wall should be neutral because it will have the same number of protons and same number of electrons. That means it doesn't have a charge. So there's no charge to the wall. The wall is neutral. But the balloon, okay, in this case, the balloon is negatively charged. How is it negatively charged? Well, you rubbed it on your hair or your clothing. That means that it's gained some electrons. So negative, you put it beside something that's neutral, it will be attracted to it. So it'll stick there. You might have done that at a birthday party where you wanted to stick balloons on the wall without using tape. That's one way to do it. Okay, charging by frictions. So neutral objects have equal numbers of electrons and protons. Okay, we determined that. When you have two insulators, such as a comb and a piece of wool cloth, they are rubbed together, the friction can cause electrons to get knocked off one material and transferred to the other material. So insulators, these are objects that are neutral. Because one object now has more electrons than protons, it is negatively charged. Now the other object having lost the electrons becomes positively charged. Okay, that's one way of charging by friction. Also known as charging by rubbing. So when you have two different neutral objects rub against each other, they become charged. Okay, notice the balloon and the hair. They are both neutral. Once you rub the balloon to your hair, okay, that's friction. Now your hair is positively charged and the balloon is negatively charged. Another way is when you drag your feet across a carpet. You gradually gain electrons. Okay, so that's the negatively charged from the carpet, giving yourself an overall negative charge. And that's why if you were to shake someone's hand at this point, the excess electrons would discharge from your body to the other person, giving both of you a shock. Or if you try that and touch a metal object like a doorknob, you will give yourself a shock. Okay, now I want you to turn to page 7 still. Okay, on page 7, you will see the electrostatic series, and that just means that scientists have conducted experiments on many materials and came up with a list that ranks how good materials are at being insulators or conductors. Okay, we're going to look at those two terms. This list is called the electrostatic series. It determines the kind of electric charge produced on each substance when any two substances are rubbed together. When charging by friction occurs, the substance higher in the list, that means the worst insulator is at the top, they always loses electrons and become positively charged. The substance that's lower in the list, they are the best insulator. Okay, they gain those same electrons and become negatively charged. Okay, this tells us that all objects begin neutral. So everything is neutral or can begin neutral, but they can become either positive or negatively charged. It also tells us a positively charged object has more positives, okay, than negatives. And then a negatively charged object has more negatives than positives. Okay, that symbol says greater. Okay, let's look at the table for the electrostatic series. Remember, on the left-hand side, these are your materials, and on the right-hand column are your charge tendencies. So the very top is human skin, and the very bottom is ebonite. Okay, same thing with, so let's start at the top. So you got human skin, rabbit fur, acetate, glass, hair, nylon, wool, cat fur, silk, paper, cotton, wood, amber, rubber balloon, vinyl, polyester, and right at the top is the ebonite. So from the human skin just about to the cat's fur, that's positive, so weaker tendency to gain electrons. However, silk, paper, cotton, wood, amber, rubber balloon, vinyl, polyester, and ebonite, they have a stronger tendency to gain electrons. Okay, so if you don't want to get a shock, you stay away from these items. Okay, now these two terms, conductors. Conductors, such as metals, are substances that allow charges to move freely through the object. So the electrons from individual atoms easily flow from one atom to another, and they do not stay in one place. So for this reason, electric charges do not collect on the surface of metals. So any material that allows electric current to pass through it, copper, aluminum, steel, basically any metal. Okay, it allows electricity or heat to easily pass through it. So if you look at the copper wire, that's the conductor. And if you're looking at the screen, you can see the rubber that's wrapped around the copper. That is your insulator. And the insulator means it's an object that prevents the passage of heat, cold, or electricity. Okay, rubber is a good insulator. So nonmetals, substances that do not allow charges to move freely through the object. The electrons tend to stay around individual atoms, and they do not flow from one atom to another. Let's look at other materials considered as insulators. Plastic, rubber, glass, wood, cloth. Okay, those are insulators. Okay, let's look at the next page. The next page shows you the support questions. Now remember, you can try these on your own. Okay, you don't have to submit them because the answers are at the end of the lesson. So support question 1 says, identify the 3 subatomic particles that make up the atom. What are the charges of these particles? Okay, can you remember them? So P, E, N, I'll give you that hint. And then what are the charges of each of these particles? So remember, protons are positive. Okay, electrons, they are negative, and then neutrons, okay, are neutral. Okay, and you can try these out. In the examples given below, tell whether there is attraction, repulsion, or neither. So if you have a positive object near a negative object, what do you think will happen? Will it attract will it repel, or nothing is going to happen to it. So remember, it doesn't matter what the object is, you just have to know what the charge is. So if you have a positive near a negative, what do you think is going to happen? Cat's fur, positive. Okay, near a neutral balloon, what do you think is going to happen? Okay, number 3 in your support question, it says a balloon rubbed with a flannel cloth will stick to the cloth. It says, do the balloon and the cloth have static electricity? If so, do they have like charges or opposite charges? So if you read this, it's telling you that the balloon was rubbed with a flannel cloth and will stick to the cloth. So do the balloon and the cloth have static electricity? If so, do they have like charges or opposite charges? Okay, it does have static electricity, especially knowing that it sticks to the cloth. So that means that they have opposite charges, okay, because unlike charges attract. Now it says a second balloon is rubbed with the same flannel cloth. This balloon also sticks to the cloth. Do the first balloon and the second balloon have like charges or opposite charges? Okay, in this case we're talking about the two balloons. So both balloons have like charges. So if the first balloon is negatively charged, then the second balloon will also be negatively charged. Finally, if the charge on the flannel cloth is positive, what is the charge on the two balloons for them to stick? So if the cloth is positive, that means the balloon or the two balloons will be negative. That's why it's attracted. Okay, now we can finish our questions. Okay, key question 68. In the examples given below, tell whether there is attraction, repulsion, that means repel, or neither. And you have to give a reason why. So refer to the laws of electric charges. So the first one, we have a balloon, which is neutral, near a comb, which is neutral. So I put in here that the balloon is neutral, meaning that it has the same number of protons and electrons. That's why it's neutral. The comb is also neutral because it has the same number of protons and electrons. So what happens to items or objects that are both neutral? Will it attract, repel, or neither? So in this case, I'll do this one. It's neither because it has no charge. Nothing is going to happen. Okay, both, and my reasoning is both objects, okay, are neutral. And I can put in brackets. That means there's no charge. So you do the next one. B, an ebonite rod. Remember I said to you it doesn't matter what the object is, you just have to know whether it's what the charge is. So if you don't know what an ebonite rod looks like, there's a picture of it down there. And then it's put beside a glass rod, which is positive. So all you have to know is whether the charge is on the objects. You have a negative object, you put it beside a positive object. Okay, what is the charge? Sorry, what will happen to it? Will it attract? Will it repel? Or neither? Okay, a negative and a positive. And then give your reasoning. Okay, next up, we've had some rain lately, and I don't believe we've had lightning yet, but our next topic is understanding lightning. We know lightning is dangerous and spectacular. It is estimated that a bolt can contain up to 1 billion volts. You can imagine the strength of the electricity. Canada averages over 2 million lightning strikes per year. 9 to 10 people are killed and between 100 and 100 people are injured each year. Okay, so what is lightning? Well, lightning is a spark that jumps from cloud to cloud or from cloud to earth. And we're looking at it because it is a form of electricity. It happens when the negative and positive charges of electricity in clouds get together. Okay, it's caused by static electricity that builds up in clouds. Lightning bolts are an example of a very large electrostatic spark. And as I mentioned, they can transfer enormous amounts of charge. So static electricity travels along the shortest path from one point to another. So if you have lightning moving from a cloud toward the ground, it will tend to strike a tall object. That's why you don't want to be standing beside a tall tree if there's lightning. So here are where most lightning deaths occur. 54% happens open fields, ballparks, golf courses. So these activities, highly recommend to not do them when you know that there's going to be a electrical storm. 23% under trees. Again, do not stand near a tree. 7% operating farm equipment. Okay, when you think about what we just went through with insulators and conductors, most farm equipments are made of metal. Okay, so you don't want to be near a conductor. 12% beach and boats. 4% is other. That means near open windows, bicycling, and so on. Okay, so how is lightning made? Well, we said that when we talk about static electricity, lightning is made in a similar way. So the electricity moves from the negative towards the positive. Some parts of clouds end up with a lot of negative charges, okay, just like the balloon. So the earth can have positive charges. So think of the earth like the cat's fur. If the difference between the two is big enough, the negative charge will be attracted to the positive charge. So a spark will jump. Remember, it's the electrons that moves. So a spark will jump between the cloud and the earth because opposites attract. The friction of water droplets and ice pellets colliding inside storm clouds also causes lightning. You see the picture there, that's also in your book. So when the difference in the charge between the positive ground and the negative cloud is great enough, there is a discharge of electrons. The result is the familiar cloud to ground lightning, also known as forked lightning. So it's forked lightning, you can see it looks like the shape of a fork. So what makes it dangerous? Well, cloud to ground lightning can strike anything in its path as it takes the shortest route to the ground. The effects of lightning can be felt after the shock occurs. Trees that have been struck can catch fire. Power surges can damage appliances in homes and businesses. And if lightning strikes a person, it can result in severe burns and even cardiac arrest. Okay, next up, lightning rods. So a lightning rod is a conductor. Okay, it's installed at the top of a tower or tall building. So its purpose is to attract lightning away from sensitive equipment and divert the strike directly to the ground. So you can see the two houses side by side. One does not have a lightning rod, the other one does. So many houses have lightning rods that stick up higher than the roof. So if lightning strikes the rod, the electricity will travel through the metal rod all the way into the ground. That way no one gets hurt and the house is not damaged. So notice the left hand house here, notice that the television has been damaged. Okay, and then finally you can check this out yourself. This is also in your book. You can go to www.canada, so Environment Canada. You can check out lightning, and there's frequently asked questions about lightning. There's also some safety tips about lightning, whether you do activities outdoor or lightning safety tips indoors. So if you look on the left hand side, avoid motors or machinery, avoiding high ground, do not swim, find shelter in building, okay, not canopy, avoid open area, crouching down and covering your ears, get inside a car. So remember, the car has rubber tires, which is an insulator. Do not carry an umbrella. Remember, an umbrella usually has a metal part there. Do not stand under tall objects. Lightning safety tips inside. You stay away from windows. Okay, do not use telephone. So in this case, this telephone is like a landline. Do not bathe. Unplug appliances. Do not wash dishes, and avoid electronic equipment. Okay, so before we go, you should try key question 69. So Benjamin Franklin was a famous American, and he discovered that lightning is a spark of electricity. Once during a thunderstorm, he flew a kite with a wire attached to it. He observed that the metal wire attracted lightning. The first question says, why shouldn't you do this? That means, why should you not do this? So there's a little blurb here. It says, one stormy night in 1752, Franklin carried out his famous kite experiment to prove, this is what he was trying to prove, that lightning is a form of electricity. He used a silk kite with a metal wire at the tip and a metal key attached to the string. Okay, those are key words. Okay, metal. When the kite was in a thundercloud, Franklin noticed parts of the string standing up like hair does due to static electricity. Franklin touched the key and there was a spark. It was an extremely dangerous thing to do, and he was lucky to survive. Okay, so part A, why should you not do this? And then part B, what can a kite act as? Okay, so do that key question. Okay, for our next class on Monday, what I want you to do is start reading page 9, beginning with what is electric current. And there's also a little activity here. Just think about all the ways you use electricity each day. Think about, if you were in town and we've had some power outages. It hasn't been long, but for half an hour, even an hour. Think about the ways that you use electricity. So you might walk into a room when there's a power outage and you still flick on the lights or the light switch, or you're about to heat something up. So maybe you're getting hungry because power's off, and then you realize there's no power. That means you can't cook your breakfast or your dinner or your supper or what have you that you want to eat. You might also use an alarm clock, or even just using your phone. Now, if your phone is not charged, okay, that means that it won't work. So that is still uses electricity. Using your computer or air conditioner, like I said, stove. So think about lights. Almost every place you go, you find electrical lighting. Okay, so think about how much do you rely on electricity, and we'll talk about that on Monday. Okay, and that's it for this afternoon. Thank you for joining me. Miigwech.